Hello, hello, chemistry. This is the second video for predicting products. The worksheet that I'm going to be pulling up, or that we're going to be using, I want to show you how to find it. It's the same worksheet that we used before, but I have made some changes. So if you go to Unit 3, Pre-Stoic, Worksheet 6, Predicting Products, this was the original image. This is what we're clicking on as the form. You're going to go to edit your response. And now there's a opening section. This is what we did on, what was that? Thursday last week. And if you hit next, there is now another section at the back. Now, these four bolded terms are the answers from the previous section. So today, what we're going to be doing is we're going to be putting these back together. Now, for the sake of your eyes and you not going blind, I am going to work this in this format so it's a little easier to see. So hopefully that will help. Now, what we're doing today, we have taken our two compounds, our two reactants, and we have split them into their cations and their anions. So what we need to do now is recombine them to form the products of the reaction. Now, there are two rules you have to keep in mind when you are recombining them. Okay? First one, a compound or a product must have one cation and one anion. Cannot have two cations. It cannot have two anions. It has to have one cation and one anion. The second rule is you cannot recombine with the same thing it was already combined with. So, for example, if we look at ammonium, the first one in this list, ammonium cannot combine with hydrogen because ammonium and hydrogen are both cations. They both have a positive charge. Since they're both positive, they can't form a bond. Okay, ammonium and hydroxide could form a bond, but that's what our reactant was ammonium and hydroxide. So it's not this one either. It has to be this one. So ammonium is going to have to bond with sulfate, and hydrogen will have to bond with hydroxide. I'm going to pull my stool out so I can reach this a little easier. So we're going to have NH4. Can you see? There we go. NH4 with +1 charge, and SO4 with a -2 charge. And then over here, we'll have hydrogen with a +1 and OH with a -1. Now, those are how they're going to pair up, but these are not necessarily compounds. Wow, you cannot read that -1 very clearly. There's a -1 right here. It's a little difficult to see. We have to charge balance these two compounds. To do that, we have to make sure that the total positive charge cancels the total negative charge, just like when we did our ionic formulae from names. So to do that, I'm going to switch colors. Now, if we look at ammonium sulfate, which is what this would be called, ammonium has a +1 charge, while sulfate has a -2 charge. So these do not cancel. What we have to do is we need to get these charges to cancel. Well, to do that, if this is +1, what times 1 will give you 2? Well, it's going to be 2. Or the shortcut, the exponent here, the number, not the sign, just the number, becomes the subscript here. So we need a 2 after the 4 because it needs to apply to all of the ammonia. So we're going to add a 2 here. Now, the problem with adding a 2 here is that makes this now NH42, which is not what we want. So we need to also include parentheses around that polyatomic ion to show that the 2 applies to the entire thing, not just the hydrogen. Going to the other one, we have H, which is a +1, and OH, which is a -1. So this one is already charge balanced. We don't have to add anything to it. And that's pretty much it. I'm going to go ahead and do the next one to walk you through to kind of give you another example. But I would suggest that you pause this first, take a crack at the second one, putting them together, and then come back and watch this. Okay, I'm now assuming that you have done that you have an answer for number 2. And I'm going to walk you through how to get it. So, don't need the stool anymore. We have sodium. So I'm going to write sodium first with a +1. Can't pair with a cation, and it can't pair with the anion it was already paired with. So it has to go with the BrO3, which is a -1. Then the lithium, the other cation, is going to go here, and the other anion will go here. So that's -1 and +1. +1 and -1 cancel, so we don't need to add any subscripts to this one. +1, -1 again cancel, so we don't need to add any subscripts to this one. That was kind of a crappy example. Oh, there is one more thing I almost forgot. Because you're plugging this into a Google form, you can't do subscripts and superscripts or exponents. So instead, what I want you to do is write this as NaBrO3, and this one would be NH4 2SO4. Okay, and then plus the other one, LiOH, and plus HOH. So that's how you'll actually type that in. I'm going to find a better example because that second one really wasn't a great example for me to say, hey, I'm going to go walk through this with you, because that was pretty easy. So let's find a harder one. Let's do this one, number 9. So again, I recommend you take a crack at number 9, this one here, on your own first. Pause the video, take a crack at it, and then come back. I can't talk. And then we will go through it, or I'll walk you through how to solve it. All right, I'm assuming you have paused the video, worked it out, you have an answer. So let's figure out what this is. So again, our first cation is iron, Fe. Now, how do I stand here so I'm not in the way? Let's try this. So Fe with a +3 charge. It can't be paired with potassium because that's another cation. It was already paired with oxygen, so it has to get paired with the dichromate. So that would be CrO7, and I forgot the 2. That has a -2 charge. And then that would leave K and O, which would be K +1 and O with a -2. So 3 and 2 do not cancel. Now, if you remember your shortcut, again, I'm going to switch colors for this. This 2 has to be the subscript here. And this 3 has to be the subscript here. But because we're adding a subscript to a polyatomic, we need parentheses. So that gives us 3 times -2, which is -6, and 2 times +3, which is +6. And +6 and -6 cancel, so this is charge balanced. The other one K is +1, O is -2, so we need a 2 here. And that's pretty much it. So from here, I'm going to kind of let you guys work it out on your own. I've done a quarter of these for you, or with you. Hopefully with you, not for you. The answers are in there. So if we go back here, you're going to have to deal with my chicken scratch on the board here. If I back out of this, well, it's like, don't back out, because if you back out, it will delete all your work. If you hit submit, instead of hitting edit response, go to view score. Here. And it's going to tell you the correct answers on section 2. So on combining, which is what we just did, it will have your answer here that you typed, and then this is the correct answer. Now, one quick clarification. It does not matter which of these is written first. For example, on this one, if OH was written before ammonium sulfate, that would be fine. That's not going to change it at all. I personally always put the cation in the same spot and then switch the anions because that makes more sense to me. But as long as your cation is written first, you should be fine. That's it for this video. I'm going to do one more for what we're doing on Wednesday, the 9th. And then from there, we'll have one additional video where we look at mixed stuff, where we talk about single replacement, combustion, and double replacement, and look at a mixed worksheet. So that will come later in the week. But that's it for this one. Have a great night, great day, great night, whatever this is that you're watching it. And I will see y'all back in class.